Hello, Algebra 2 students. Today we're going to look at inverses. We've studied the topic of inverses before, but we're going to look at the relationship between square root functions that we've been studying the last several days and inverses. So here we're going to just warm up a little bit. It says solve each equation for x. Remember, these equations usually have two solutions. So the first one is x squared plus 21 equals 70. So remember, because that one doesn't have just an x term, that we can just subtract the 21. And 70 minus 21 is 49. Take the square root, and you get plus or minus 7. Okay. Two solutions, 7 and negative 7. This one says 4x squared minus 12 equals 13. Again, we've got an x squared term, but no x. So we can solve by taking the square roots. We're going to add the 12. Which gives us 4x squared equals 25. Divide both sides by 4. Okay, so then we have, you know what? I'm going to switch this so that you can see there's just not enough room in that little box. Okay. Let's start that one over. So this is letter B on your paper, and it says 4x squared minus 12 equals 13. Okay, so then you would add the 12. That's where we have 4x squared equals 25. Divide by the 4. X squared equals 25 over 4. Now, do you notice those are both perfect squares, 25 and 4? I would not change this to a decimal. I would leave it as a fraction. The next thing we're going to do is square root. So then I have x equals plus or minus 5 over 2, because the square root of 25 is 5 and the square root of 4 is 2. And there are your two answers. Okay, let's look at letter C. Letter C is x minus 3 squared plus 4 equals 40. Subtract the 4. Take the square root. That's an equal sign there. If x minus 3 equals plus or minus 6. Where did 6 come from? It's the square root of 36. Now, we're going to add the 3 to get the x by itself. So we have x equals 3 plus 6 and x equals 3 minus 6, which means x is 9 or x is negative 3. And there you go. That's just a little reminder. Now, let's keep going. And let's go back to your paper. This says a review of quadratic functions. You'll find out in a minute why we're doing some review of quadratics. It says, for the equation y equals x squared, complete the table, then plot the points to construct the graph. Okay, this is y equals x squared. That's our equation. So we take each x and we're going to square it. Negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared, 2 squared, 3 squared. Okay. It says if the domain of the equation is negative 3, negative 2, domain is the x's, then the range would be 9, 4, 1, and 0. Okay. That's your range because that's the y's. We're supposed to plot these and make the graph. So I have negative 3, 9, and negative 2, 4. One, 2, 3, 4, 5, 6, 7, 8, 9. I missed that one. That's, I can't count today. Okay, negative 3, 9, 1, 2, 3, 9, all the way up here at the top. Negative 2, 4, right here. Negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Look what happened when we plotted those points. We made a parabola. Okay? Now, think back to the beginning of the year when we talked about inverses and we learned some things about inverses. And we said that inverses, you switch the x and the y. This part says the inverse with coordinates. Recall that an inverse can be formed by switching the x and y coordinates in a relation. Use this method to make a table and a graph. So in the first table, that -3, -2, -1, those were the x's. Now they're the y's. What's going to be the x's in this table? It's the 9, 4, 1, 0, 1, 4, and 9 that were the y's. So we switched the x's and the y's from the first table to this one. Right? Is this inverse a function? Oh, we skipped that question on the first one. When you look back at the first one, this was, give me a second, 9, 4, 1, 0, 1, 4, 9. Is this equation a function? Remember our graph? I'm just going to sketch it real quick. Look kind of like this. It is a function because the x's do not repeat and the graph passes the vertical line test. Okay, do you remember that? All right, now let's look back at the second one. And look what we did. We took the x's from the first table, now they're the y's. The y's from the first table are now the x's. So we have, waiting for it to let me write. Here we go. 9, 4, 1, 0, 1, 4, 9. Okay, so we've switched the x's and the y's from the problem number 1 to problem number 2. It says, is this one of, oh, we need to graph it. It's the end of the day here. I'm not doing so hot. Okay. 9, -3. There's 4, 5, 6, 7, 8, 9, 1, 2, 3. 4, -2. 1, -1, 0, 0, 1, 1, 4, 2, 9, 3. What happened to our parabola? Kind of flipped over, didn't it? You remember we talked about that an inverse, a function and its inverse are reflected over the line y equals x. So this is number 1, and this red one is this problem number 2. Okay, is this red one a function? No, it's not. It's not because 1, your x's repeat. You got a 9 and a 9, you got a 4 and a 4, and a 1 and a 1. Look here, the vertical line test does not pass. It crosses twice. So it's not a function. Fails the vertical line test. Or you can put that the x repeats. Either way. Okay. So we know we can make the inverse with coordinates. We can switch the x's and y's in the table or switch the x's and y's in the graph, and we can make the inverse. Okay. If you recall from the beginning of the year, how do you make the inverse? You switch the x and the y. Okay. Now, number 3 says find the inverse with algebra. It says remember that another way to find an inverse is to switch the x and y variables in an equation, then solve for the new y. Here's our equation was y equals x squared. That's the equation from number 1. The inverse, we're going to switch the x and the y. Now, the second step is to solve. You can't forget that second step. How do we get that y by itself? We're going to take the square root, take the square root. This, remember this little symbol? This guy means inverse, okay? Means inverse. So inverse is square root of x. It says use a calculator to help you sketch the graph of this inverse. This inverse looks like this. Does this match our answer from number 2? If you look back at number 2, we're missing here, this bottom part. You remember how many times I've talked to you about putting the little plus minus in front? When you just graph the square root of x, you get the top half. If you graph negative square root of x, you'll get the bottom half. Okay? Normally, we just graph the top half right here and call it the square root function. Okay? We just graph the top half and call it the square root function, which we've been studying all of this week. Okay. This says these two relations are inverses of one another. Okay? Let me turn my page over here. It says, what are the properties of inverses? Their graphs are reflected over the line y equals x. The equations have the x's and y's switched. Okay. This graph, the equation was y equals x squared. The shape was a vertical parabola. We've talked about parabola before. Vertical just means the parabola goes up and down. Then this graph that we did in number 2 was this. The equation is y equals square root of x, or x equals y squared. Let's do it this way. So when the x is squared, it opens up. When the y is squared, it opens sideways. You'll study more of those once you get past algebra 2. This shape is a horizontal parabola. The next question under there said, what's the problem with this graph? I don't know if it's really a problem, but this one is a function, right? The one on the left is a function. The one on the right is not a function. This one is a function. This one is not a function. What? What's the problem with this graph? This graph is not a function. Technology does not want to cooperate today. So normally we just graph the top half and call it the square root function, which looks like what we've seen on the board and all in your assignments all of this week. Square root function. Okay, it's just the top half. Okay. I'm going to go ahead and cut that off and move this up. Okay, so here is some information about your square root function. Here's the parent function of y equals square root of x, which is here. There's a table in this equation for this function where x is 0, y is 0, where x is 1, y is 1, where x is 4, y is 2, because 2 is the square root of 4, where x is 9, y is 3. We graph those, 0, 0, 4, 2, 9, 3. Okay. It's a pretty thick line there. The domain is x is greater than 0. You could only use positive values for x. The range is y is greater than 0. And we've talked about this week. You will only get positive answers. Can't spell and talk. For y. This is our parent function. This is nothing new. We've talked about this all week. Y equals square root of x. The end point's at 0, 0, and it goes up and to the right. The domain is x is greater than 0. The range is y is greater than 0. Okay? The x values are positive. The y values are positive. Okay. This says a review of quadratic functions. It's going to talk about a little bit with transformations that we've talked about. Okay. So this number 4 says, For the equation above, complete the table, then plot the points to construct the graph. You could type this into Desmos and get your table, or you could plug each one of the numbers in the table, each one of the x values in, and get your y. It'd be quicker to go to Desmos. I'll tell you that this table where x, for this equation right here, where x is -2, y is 6. Where x is -1, y is 0. Where x is 0, y is -2. 1 and 0, 2 and 6. Let's plot those points. -2 and 1, 2, 3, 4, 5, 6. -1 and 0. 0 and -2. 1 and 0. 2 and 6. So this parabola, you can tell, has been moved down 2, and it has a vertical stretch. It's narrower, skinnier than our x squared. This graph is a transformation of the parent graph. Tell how each constant in the equation, this -2, that's a k. Yeah, it's not in vertex form. That's okay. This -2, you can tell from the graph, moved it down. Okay. Guess we should say translates or slides down. The 2 coefficient on the graph has a vertical stretch. It just doesn't have an H. It has a and it has a K, but it doesn't have an H. Okay. We could also write that as 2 times x minus 0 squared minus 2. It's the same thing because this is 0, which gives us the same equation as that. Okay. So let's look and see what's next. Recall that an inverse, here they want you to make the inverse. So what are you going to do with the x's and the y's? You're going to switch them. So now the -2, -1, 0, 1, and 2 that were the x's are now the y's. What are the x's going to be? 6, 0, -2, 0, and 6. And then what are we going to do? It says, recall that an inverse can be formed by switching the x and y coordinates. Use this method to make a table and a graph. Okay, I was trying to see if they want us to graph it yet. 6, -2, 0, -1. What do you think this is going to look like? -2, 0, 0, 1, 6, 2. There's that sideways parabola. Is the inverse a function? Look at your x's. Do they repeat? They do, so it's not a function. Look at your graph. Does it pass the vertical line test? No, it does not. Either one of those by itself is enough to tell you this is not a function. X repeats, or you can put fails the vertical line test. Okay. All right. Next. Inverse with algebra. So with algebra, we're going to switch the x and the y, and we're going to solve for y. Remember, there are 2 steps to that. You cannot just switch the x and y and be done. You have to switch the x and y, then solve. So when we switch it, we have x equals 2y squared minus 2. Now we have to get the y by itself. Okay. Add the 2. Divide by 2. So then you have x over 2 plus 1 equals y squared. How do we get rid of squared? I'm going to square root. So now we have square root of x over 2, or you could write that 1/2 x, same thing, plus 1 equals y. When you graph that, let's going to look something like this. Again, remember, it's just the top half. If we put this little plus minus here, then we would have the bottom half also. Trying to make a dotted line there. Didn't work very good. Does this graph match your answer from number 5 without the plus or minus? No, it does not. Okay, no bottom half. Remember with this, it says we usually just graph the top half and call it a square root function, because if we graph the bottom half, it's no longer a function. All right, what I'd like for you to do now is pause the video and work. You have 2 problems left, number 7. Actually, you have 3 problems left, 7, 8, and 9. I'd like for you to work. You're going to do the same thing. You're going to take an equation and get the table and draw the graph. And it's going to ask you about the transformation. And then you're going to make the inverse by switching the x and the y. And then you're going to draw that graph, and then you're going to make the inverse from the equation by switch the x and y and solve for y. So I'd like for you to pause the video, do number 7, 8, and 9 in your packet, and then turn the video back on so you can check your answers. Okay. Welcome back. I hope you paused and tried to work these on your own, so you can see if you know what you're doing, see if you know you understand. All right, number 7 says x minus 3 squared minus 1. We know about transformations. We worked on those on Wednesday or Tuesday. X minus 3 squared minus 1. What does this minus 3 do? It's going to move it to the right, 3. And this minus 1 goes down 1. I don't know. I just skipped to those. It was pretty easy. For the equation above, complete the table, then plot the points to construct the graph. Your y values are 8. Whoa, sorry, cannot write with that. 8, 3, 0, negative 1, 0, 3, and 8. Plot the points to make the graph. 0, 8. 1, 3. 2, 0. 3, negative 1. 4, 0. 5, 3. 6, 8. There's our nice, pretty parabola. All right. Now, I'm going to make the inverse. So we're going to switch the x's and the y's. So the x's become the y's and the y's become the x's. So here we have 8, 3, 0, negative 1, 0, 3, and 8. Plot these points. 8, 0. There's 4, 5, 6, 7, 8. 3, 1. 0, 2. 1, 3. 0, 4. 3, 5. And 8, 6. Oh, that is a horrible looking parabola. Should be rounded. Is this inverse a function? No, it's not. The x's repeat. Pat fails the vertical line test. VLT, vertical line test. All right, the next part says to find the inverse with algebra. So again, to find the inverse algebraically, you switch the x and the y. And then solve for y. So we're going to add the 1. Square root both sides. Add the 3. Oop, I forgot to add the 3. Notice that the 3 is not under the square root sign because we square rooted first and then we added the 3. Okay. There is our new equation. This notation, I ran out of room, is the inverse of f of x equals the square root of x plus 1 plus 3. The graph looks kind of like this. Does it match from number 8? Nope, it's only the top half. Okay. That's it, guys. That's squaring and rooting inverses. What we should have learned from this is that square root functions and quadratic functions are inverses. Their graphs are reflected across the line y equals x. You can make one into the other by switching the x's and y's in the table, or in the equation, switch the x and y and solve for y. Have a wonderful day.